Hi friends, welcome to my channel. Today we are going to solve LeetCode 56 problem, merge intervals. Okay, so let's go through the problem. We are given an array of intervals where interval I represents start of I and end of I. Always start of I less than end of I. So we need to merge all overlapping intervals and return an array of non-overlapping intervals that covers all the intervals in the given input array. So let's understand from the given example. Okay, so this is the example. So suppose if we consider, okay, so this is the timeline. So this is 1 2 3 4 5 6 7 8. Okay, so 1 2 3 4 5 6 7 8. Okay, so if we take 1 to 3, so this is the first interval. Okay, so second interval is 2 to 6. So this is 2 to 6. Third one is 8 to 10. Fourth one is something around 15 to 18. It is not overlapping. So if we consider interval 1 and 2, these two are intersecting. From the diagram, you can clearly observe these two are intersecting. So we need to merge intersecting intervals. So after merging 1 3 2 6, result would be 1 6. For other intervals 8 10 and 15 18, these two intervals are not intersecting with any other interval. So directly we include those intervals in the result set. So only we will merge intersecting intervals. Those are 1 3 and 2 6. Okay, so let's go for the approaches to solve the problem. Before going to different approaches, let's understand basic interval related operations which are required. Okay, so first of all, how do we know two intervals are intersecting each other? Suppose if we take two intervals A0 A1 and interval B0 B1. So if these two are intersecting, always this condition would be true. A0 should be less than or equal to B1. In similar way, B0 should be less than or equal to A1. So let's understand this particular thing from this particular validate this. So in case of 1 3 2 6, so 1 should be 1 is less than 6, that is true. 2 is less than 3, this is also true. So these two are intersecting. In similar way, if you observe 8 10 and 1 3, so 1 is less than 10, this is true, and 8 is less than 3, this is false. So second condition is failing for these two. So these two are not intersecting. So you can understand with more examples. So second operation would be, so how to match intersecting intervals. So this is also we require for this particular problem. Suppose if we take 2 points, same points A0 A1 B0 B1, so merged intervals would be A0 new 0 new 1. So for new 0 new 1, formula would be new 0 should be okay, so min of A0 B0. Okay, so N1 should be max of A1 B1. Okay, so these also you can understand from given these two. So if we merge 1 3 and 2 6, 1 3 and 2 6, actually it would be start should be 1 and end should be max of 3 comma 6, so that is 6. Okay, so these are the two basic operations which required. Yeah, we can solve this problem using two approaches. First one is the naive approach. In naive approach, we use nested loops. Two for loops we will use. Okay, so these for loops, j is always starts from I plus 1. So in this, actually we have some, we need to consider some result set. Okay, so suppose we will compare each pair. So if I is not intersecting with any of other intervals, we will add this particular interval I to the result set. If it is intersecting, we will merge I with the j and we will update the j. So let's dry run this particular this particular input array. So I is 0, j equal to 1. So are these two intersecting? 1 3 and 8 10, these two are not intersecting. So let's increment the j. So now if j points to next index, so 1 3 and 15 18 intersecting, no, these two are not intersecting. So we will simply go for next item. So here ij 1 3 interval and 2 6 interval are intersecting each other. So we know formula, right? Actually, if two intervals are intersecting, this is the formula. As per this we will update this. Okay, so and we won't add to result set. So if we merge 1 3 and 2 6, result would be 1 6. So I have updated index j. So now let's move to the next iteration, next outer iteration. So now I points to the 1 and j points to the I plus 1. Okay, so are these two intersecting? No. So next we will check these two. So, this 8 10 and 1 6 are intersecting. These are not intersecting. So we simply add this 8 10 8 10 to the result set. Okay, now next move to the next iteration. So I is now this and j is this. So are these two intersecting? Okay, so if you check as per this condition, these two are not intersecting. So as 15 18 not intersecting with any other, we will add these two result set. Okay, in similar way, now I and j, I points to the last one. For that, we need not to validate letter, so we directly add that to result set. So it is 2 comma 6. This is the final result set we need to return. So let's go through the time complexity. So what is the time complexity for this particular approach? Time complexity is we are running two for loops, right? Order of n square. So this is not the optimal solution for this particular problem. We have approach 2 which is optimal. Let's discuss approach 2. Now let's understand the approach 2. Approach 2 is based on the sorting. So before going to approach 2, let's discuss pain point in approach 1. So in approach 1, where exactly we are struggling? We are struggling to identify intersecting interval for current interval. So suppose to check to identify intersecting interval for this 1 3, we are simply checking with all other items of the input array. So similarly, we are doing same operation we are doing for all n items. So it is causing n square time complexity. So to solve or to reduce the time complexity, we will sort the input array. We sort based on the start of the interval. So this is the input array, right? If you observe this, we sorted based on the start index. 1 came first, 2 came second, 8 came third, like this. So this is the technique we use to sort. Once this is prepared, so in approach 2, okay, so to identify the intersecting interval, we need not to check with all other items. If you simply check with the previous item, that's enough. Okay, so that tip helps a lot in approach 2. So let's dry run this given input. Okay, so before dry run, let me clarify one thing. So simply we will check a current item with the result set last item. Okay, so very first time we will add first item to the result set, that is 1 3. So we always start from index 1. So if current interval intersects with of result set, we will update result set last item. So if it is not intersecting, we simply add current interval to result set. So this is the technique we follow. If current interval is intersecting with the result set last item, we update the result set. If it is not intersecting, we simply add current interval to result set. Let's dry run now. So we are at index 1. So 2 6 and 1 3, are these intersecting as per this? Yes, these two are intersecting. So as per this technique, so as per this first step, we need to update the result set. So once if we merge 1 3 and 2 6, result would be 1 6. We will update. Okay, next move to the next item. So 8 10, this 8 10 is intersecting with 1 6? No. So we simply add 810 here. So to add 810, what we followed? We followed this second step. Okay, so in similar way, let's move to the next interval. So this 1518 is intersecting with 1810. No. So here also we follow this second step. So as per that, we will add 15 to 18. So this is the final result we need to return. So coming to time complexity, what is the time complexity? For sorting, it is taking n log n time. Okay, so and to prepare this result, we are iterated the sorted array once, right? So it taken order of n time. So overall time complexity would be n log n. So let's code this approach 2 as it is the optimal one. So let's code the approach 2. So first of all, let me declare result set. Okay, so then we need to sort the array. We already discussed how to sort, so we need to consider start indexes. If start indexes are same for two intervals, then we need to consider end index. Okay, return b of 0 not equal to b of 0 of 0 minus 0. If they are same, then we need to consider f1 minus 1. We sorted based on start indexes. If start indexes are same, we are considering the end indexes of the interval. Now we are done. So we will to iterate current interval. Okay. Now last result index equal to the index. So last index greater than or equal to 0 and get index. So current result set end item, if it is greater than or equal to current interval start index, that means it is intersected. So yes, already it is sorted, right? So always first part of the our formula is true. So we discussed in the previous discussion, right? That is always true. Yes, it is the sorted array. Okay, so if it is intersected, what we need to do? We need to update the result set. Index result set end time we are updating. Okay, so current interval max of these two. Okay. If interval is not intersected, then we simply add current interval. Okay, so we are done. We simply return result. Oh, we need to return array of integer array, right? So let me convert. So basic test cases are passed. Let me submit this. Yeah, it's submitted and it beats the 96% of submitted solutions. Yeah, thanks guys for watching my video.